Alright, welcome. In this video I'm going to show you tangential tacheometry. Alright, so let's get started. So the stadia tacheometry is a little different. Subtense, this is kind of like subtense, but at an angle. So let's say your tripod is down here and your instrument is pointing up, and you're on top of the hill here, and you got a bar, a rod, a vertical rod, a straight rod preferably, and so you got a mark here on the ground. Again, it's going to be in the face. You want the face of the bar above the pin. So that's your pin, like that. So it's in line with the face. And now you've got your inclination, your angle here, your vertical angle. So you're going to record the vertical angle. Nah, that's terrible. Vertical angle. And then that's pretty much, so here we go. So you're going to start kind of over. There's a tangential tacheometry. So you're going to hit 2 points. You're going to go kind of low to the bottom and up towards the top. You're going to record those angles. You're going to let's call this one angle A and angle B. You're going to go angle B minus A. And that's going to give you this. And I'm not even sure if I remember if we need that or not. I don't think so. So that's not happening, so forget that. Just record the vertical angle A and record vertical angle B. So let's just say, right now, we'll put some numbers to it. Let's say A equals 20 and B equals 25. And what we're going to do is we're going to record these numbers here. You don't record, there's no, the stadia, the crosshair, the center is here, and it's a separate shot here. Your stadia hairs are not involved in this tangential tacheometry. So let's see if I can remember how this works, right? So I don't remember. I have to kind of scratch my head here for a second. Alright, so we've got an angle here, and we got this, and so we're looking at this. So theoretically this goes down here like this. So we've got angle A, so angle A, let's see, and we have angle B. I forgot. I'm working it out with you guys. And you know that this angle and this angle, and we have this dimension here. There we go. So let's say call that 5, right? So angle B. So then we're going to do, I think what we're looking for is we're going to go for this. If I don't remember, it's called tangential for a reason. So we're looking at this. So we're going to call this H. So 5 plus, we'll call this, what do they call this in the books? S, I think. Let's call it V. So 5 plus V over H is equal to tangent of A, right? 5, I'm sorry, B. And we have angle A, so V over H is equal to tangent of A. I think we're going to call A 20 and B 25. Alright, so now, but that's regardless, so I don't know if I can move this stuff up here. No, it doesn't look like it. So let's just move over. So what we have here is we got V and H, which is two unknowns. We have angle B, we call that 25. And angle A is 20. So we have a V and an H, two unknowns. But what we will do is sort of like if you ever derived the law of cosines, we're going to solve each for H, okay? So V plus V, 5 plus V over tangent of 25, 5 plus V over tangent 25 is equal to H, right? Because we solved for H. And over here, we're going to say is equal to, we're going to solve for H here too. So we're going to go V over tangent of 20. So now these are equal. So I think the easiest way to do it is to cross multiply. Algebra is not my favorite thing to do, but it's pretty useful here. I don't know how to do it without algebra. So we're going to go tangent, no, we're not going to go tangent 20 times 5 plus tangent 20 V. Right? That's this one's. And then is equal to tangent of 25V. V, let me make sure I got that right. Tangent 20. So if you multiplied that by that, you get tangent of 20 plus tangent of 20V. Tangent of 20 times 5 is tangent of 20V. Cross multiply that, you get tangent 25V. So we have like terms here, so we could go minus tangent 20V, and we could get tangent of 25, so that cancels out. It goes to the other side. This one here, we can solve for that. Let's go ahead and see if we can do that then. 20. I should have paid more attention to what we were looking at, right? The first one was tangent of 20 times 5. So let's clear that out. 20 tangent of 20 times 5 equals 1.81. We'll call it 8182. 1.82. So 1.82 is equal to tangent of 25 minus tangent of 20. Tangent minus 20 tangent equals 0.1023, 0.1024, 0.1023, yeah, 0.1023. Yeah. So we got 0.1023 equals 0.1023 V, right? And then we'll divide both sides by 0.1023. Let's cancel. That's 0.182, 1.82. Divided by 0.1023, right? This might work. It's been a while since I looked at it, right? So 1.82 divided by 0.1023. I always had trouble with this. It always never has the numbers in there. There it is, 102.337. And equals, there we go, we got 17.78. So the V is equal to 17.785. So now we can check that. We go 22.785 over, we don't have any other information. We got this, and we can solve for H, right? So let's do that. We know this is 25. Let's get rid of that. 25. This is 20. So we're going to go over H is equal to tangent of 25. So we'll solve for H. Let's solve for that. 22.785. Divided by 25 tangent equals 48.87. So here we go, switch 48.87. So let's just check that. So 22.785 divided by 48.87. Well, arc tangent dash should turn out to be the diagonal here. I mean, should arc tangent up to 25. So let's check that. So we got, that's a stored number. We're going to go 22 point, I don't think it's over here. 22.785 divided by 48.87 equals trigonometry second function tangent. We get 25 degrees. That's just not rounded. So that works out. I mean, if you followed the numbers all the way, it would do it, but it's having a little trouble going back and forth to the calculator. So that atan, so let's do this. To check it, we did 22.785. If you carry the numbers over, you'll see over 48.87. And you go to the negative tangent. I think it looks like something like that. And then you'll get equals 25 degrees. So that works out, and then all you gotta do is go 17 over the same number. So let's do that, 17.785. So we'll go 17.785 divided by 48.87. Oh, no. 0.87 equals trigonometry second function tangent, and we get 20 degrees. So that's how it works. And then Not that that's what your goal is to close out, but then we get the 20 degrees closed out. It was 17.785 over 48.87 negative tangent, and we end up with equals 20 degrees, right? So that works out, and then that's not your goal to get them to close out, but you have to check, and then you could just use Pythagorean theorem and get your diagonal. But what do you need the diagonal for, right? So you're just looking for the horizontal distance and the vertical distance, and then you would take the vertical distance, right, and then you would subtract this. This is the number that we did, right? Let me erase this. So the hill's here, right? We actually got this dimension. That's that 17.785 from here to the ground, or from here to the instrument, right? Instrument height. And then you would deduct this dimension right here above the ground. And you would have your height above, whatever that is. You'd have 17.785 minus whatever 1 foot, and you would end up with your height of the pin above the height of the instrument. That's how tangential tacheometry works, as far as I know. And I hope that helps you in your career. And thanks for watching.